Welcome to GMST Davangere. I am Anil Kumar TRB, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the experiment number 10. So that is a single phase IGBT based PWM inverter. Contents: aim of the experiment, theory, part is required, circuit diagram, procedure, calculation, results and graph. Aim to study the operation of a single phase IGBT based PWM inverter. When you talk about the theory, it consists of 4 IGBTs, that is S1, S2, S3 and S4, and 4 inverse parallel diodes, that is D1, D2, D3 and D4. The diodes are essential to conduct the reactive current, thereby to feedback the stored energy in the inductors to the DC source. These diodes are known as the feedback diodes. So for the many industrial applications, the output AC voltage of the inverter must be sinusoidal in the shape, the amplitude and the frequency must be the controllable. This can be achieved by the PWM of the inverter switches. The switching sequence of the inverter switches in this case is obtained by the comparing the sinusoidal control signal of the adjustable amplitude and frequency with a fixed frequency triangular carriers. So let us see the circuit diagram. So we have the IGBT, 4 IGBTs we have. Along with we need to provide the gate signal to all the 4 IGBTs from the firing circuits. Part is required, that is a single phase PWM inverter study unit. We have the CRO probes and certain connecting wires. Procedure: when we go to the procedure, we make the connection as per the given circuit diagram. Connect the gating signal from the inverter module. Switch on DC of 24 volts. Keep the frequency knob to the particular frequency. Observe the rectangular and the triangular carrier waveforms in the CRO. We have to obtain the output waveforms across the load resistance. So this is actually the tabular column. In this tabular column, we need to see what is the output voltage and the time. So this is actually the graph that we are going to obtain in the CRO. We have the modulated wave and the carrier wave. These are the comparisons to get the high frequency and the low frequency. Result: the operation of the single phase IGBT based PWM inverter can be determined easily. So let us see how this can be obtained in the real time by conducting the experiments of the PWM inverter circuits. Hi, hello everyone. I am Anil Kumar TRB, Assistant Professor, Department of Electrical and Electronics Engineering, GMST Davangere. So today we are going to study the single phase IGBT based PWM inverters. Our aim is to study the operations of a single phase IGBT based PWM inverter. For that we require the DC supply. For that we require the DC supply of 30 volts and 2 amperes. So we have set for the 10.2 volts and 0.1 amperes. And this is the single phase PWM inverter IGBT based kit, and this is our load resistance. This is a load resistance of 50 ohm bar 100 ohm bar 2 amperes. So in the single phase PWM inverters, we need to set the types of the output waveforms that we require. As again the DC voltage of 10 volts and output we have set for the sinusoidal PWM. So modulation I have set for the 0.5 and frequency can set for the 50 Hz. So once all these has been set, we have to go for the run options. So when you start running the options, right? So we have to give, this is actually we have to give the signal from the signal circuit. That is, we have to set the gate and the emitter signal to the output of the kit. From this kit, once we set the run and stop, we can observe the waveforms across the CRO. So this is actually our output waveforms for the sinusoidal waves.